This presentation examines the mean and variance of discrete random variables. So our definition is that a discrete random variable will have numerical outcomes, and each outcome will have an associated probability. So for example, if you toss 4 coins and count the number of heads, you could have 0 heads, 1 heads, 2 heads, 3 heads, or 4 heads, and each one of those will have a probability. So here's Pascal's triangle that we can use to get those probabilities. 1 plus 4 plus 6 plus 4 plus 1 is 16. Probability of 0 heads, 1 out of 16. 1 heads, 4 out of 16. 2 heads, 6 out of 16. 3 heads, 4 out of 16. 4 heads, 1 out of 16. We put those together, then we get our random variable. Again, notice numerical outcomes, and each outcome has an associated probability. Now, if we roll 2 dice, can we do the same sort of thing? Remember, if you roll 2 dice, your outcomes are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, etc. So I have those 1, 1, 1, 2, 2, 1, 1, 3, 2, 2, 3, 1. And you'll notice that 2 shows up 1 time out of 36. 3, these two guys, shows up 2 times out of 36. 4 shows up 3 times out of 36. So again, we can construct our random variable, which will consist of numerical outcomes 2 through 12, each with an associated probability. Now, once we have random variables, we're going to want to do something with it, namely identify the mean and the variance. So here's our rule. If we have a random variable, the mean, mu of a random variable, is simply going to be the sum of x times p. And the variance is going to be the sum of x minus mu squared times p. And of course, the standard deviation is simply the square root of the variance. So let's take a look at our example of flipping 4 coins. We have our random variable, 0, 1, 2, 3, 4 are our numerical outcomes. 1/16, 4/16, 6/16, 4/16, 1/16 are the associated probabilities. And then we're going to find the mean using Excel. So our possible outcomes here, numerical outcomes, we have 0 heads, 1, 2, 3, 4, and then we had 1/16 equals 1 divided by 16. 1/16, 4/16 equals 4 divided by 16. 6/16 equals 6 divided by 16. 4/16 and 1/16. So there's our random variable, numerical outcomes, each with an associated probability. To get the mean, we have to multiply x times p. So we're going to say equals the x number times the p number. Then we're going to scroll those guys all the way down. Equals the sum of all of those numbers. So what we get here is, we get our mean mu is going to equal 2. So indeed, that's how we're going to calculate the mean of a random variable. Now our next question is going to be to find the variance and the standard deviation. So we need the sum of x minus mu squared times p to get the variance. So back to Excel. Equals x minus mu, which is 2, squared. Of course, 0 minus 2 squared is 4. And we're going to work those guys as follows. Then we're going to multiply the x minus mu squared times p to get our variance. And then our variance will be the sum of all of those. So equals the sum of those numbers, and we get 1. So the variance is 1, and the standard deviation would be the square root of 1, which of course is also 1. So we see that our variance is 1 and our standard deviation is 1 for this example for flipping 4 coins and counting the number of heads. You can check that on Minitab, random 1,000,000 C1 binomial 4 trials, Probability of success on a given trial is 0.5. So that's one way to describe flipping coins. And we're going to go ahead and look at the descriptive statistics. You see we get a mean X bar of 1.9998, very close to 2. A standard deviation of 0.9997, very close to 1. And our theoretical numbers indeed were mu is 2, sigma is 1. So our mini-tab results reinforce what we did theoretically. Okay, if we're going to roll 2 dice and compute the sum, we want to find the mean, variance, and standard deviation for that. So here's our table. Our x's go from 2 to 12. Our probabilities, this corresponds to 1 out of 36, 2 out of 36, 3 out of 36, 4 out of 36, 5 out of 36, 6 out of 36, 5 out of 36, 4 out of 36, 3 out of 36, 2 out of 36, 1 out of 36. This column corresponds to x times p, so 2 times 0.0277 is about 0.055, etc. We add up all of those numbers to get our mean, and our mean turns out to be 7. Then we want to take x minus mu squared. 2 minus 7 squared, 25. 3 minus 7 squared, 16, etc. This is our x minus mu squared column. Then we've got to take these numbers, x minus mu squared times p. So 25 times 0.0277 will give me about 0.6944. We sum all those numbers and we get the variance. And of course the standard deviation is simply going to be the square root of the variance. And certainly these types of computations are best done on a spreadsheet like Excel. So theoretically we're going to say our mean of this random variable is 7, our variance is 5.833, and our standard deviation is 2.4152. Checking this on Minitab, a million numbers in C1 and C2. Those numbers are all of the form integer 1 through 6. That is going to best simulate rolling 2 dice. And then by adding them together, we're going to get the sum. Asking for the descriptive statistics, we will see that the mean 6.9987, very close to 7. Standard deviation 2.414, very close to our theoretical standard deviation. Mean, of course, was 7, and our theoretical standard deviation 2.4152. And again, Minitab gives us a very good approximation for our theoretical solutions. Now we're going to look at a spinner. So imagine there's a carnival game that costs $3 to play. You spin the spinner and then win the amount of money indicated. Now looking at the spinner, it looks like $1 shows up half the time. It looks like $2 shows up a quarter of the time. 3 and 5 each show up an eighth. So putting those together, we can make our random variable. Again, numerical outcomes, each with an associated probability. X, 1, 2, 3, 5, with probabilities a half, a quarter, an eighth, and an eighth. So next we want to find the mean, variance, and standard deviation of this data set. And to do that, again, we're going to use Excel. So my numerical outcomes are 1, 2, 3, and 5. 1, 2, 3, and 5. The probabilities are 1 showed up a half, 0.5. 2 was a quarter, 0.25. 3 and 5 were an eighth, so it'll be 0.125. 0.125. And to get x times p, we're going to multiply those together. Equals x times p. And then add all those together, so we'll autofill first. Sum them. Equals the sum. And we have 2. So our mean, mu, equals 2. To do this, we're going to say equals the x value minus 2 squared. And then we'll autofill all those guys down. And then we need that column times the p column. And then we'll autofill all those. And if we sum those, it'll give us our variance. So our variance should equal all of these guys. And then our standard deviation should be the square root. And so indeed, for this example, variance 1.75.